Hello friends. Welcome back to the videos on Vedic mathematics. So today we'll discuss a new topic, and that is non-standard basis. Already we have discussed the concept of standard basis. Now what are the standard basis? Standard basis are the powers of 10. So 10, 100, 1000, these are the standard basis. But many times by taking standard base, if you do the calculations, it becomes difficult. And hence we consider the non-standard basis. So to make the concept of non-standard basis clear, let us consider certain numbers where corresponding standard basis and the non-standard basis that we can consider. So first let us consider the number, say 22. Now since 22 is a two-digit number, the standard base I can take it as 10. But taking the base 10, if I do the calculations, it will be slightly difficult because the difference between 22 and 10 is 12, which is quite large. So what I'll do is I'll take the nearest multiple of 10 to 22, and that is 20. The 20 will be taken as the non-standard base. Taking 20 as the non-standard base, if I do the calculations, the difference between 22 and 20 is just 2. So it will become easier. Now take another example, say 65. Again for 65, the standard base is 10. And the nearest multiple of 10 to 65 is 60. I can take the non-standard base as 60. Now take the example of 125. Actually, for 125, the nearest standard base is 100. But the difference between 125 and 100 is 25. And secondly, there is no multiple of 100 other than 100 itself, which is closer to 125. And hence, in this case also, I will take the standard base as 10 and non-standard base as 120, which is 12 times the standard base. Similarly, suppose I have 602. Then the standard base for this number is 100. And I can take the non-standard base as 600. This is the concept of non-standard basis. So today, we'll see some products, some multiplications in which multiplication in which both numbers we multiply are above a non-standard base. So first let us consider the example 65 multiplied by 69. Now for 65 and 69, I can take the standard base. That's 10, because both are two-digit numbers, and the non-standard base is 60, and 60 is 10 into 6. That means the non-standard base is 6 times the corresponding standard base. Now the method here is very similar to the multiplication using the standard basis. So I will write 65 and 69, one below other in the first column. Now 65, since the non-standard base is 60, 65 is 5 above 60, and 69 is 9 above 60. So multiply these two, that gives 45. And if I cross add 69 plus 5 or 65 plus 9, both will give me 74. Now, keep it in mind that here, the first cell, the number to the right of the partition, represents the units place, and the units place remains same in any base. But second number in the left partition is a number that is in base 60. I want to change it to the standard base 10, and 60 is 6 times 10. So I will multiply 74 by 6. And that will give me 444. So let us write this as 444 in the left partition and 45 in the right partition. Keep it in mind that the standard base is 10. That means on the right, in the right partition, there can be only one digit, because 10 has 1 0. I'll carry forward this 4, or 444 plus 4, that is 448 here. And now write both these numbers together. So 65 into 69 should give the result 4,485. So let us consider the second problem here. So let us move to the second problem. Let us multiply 122 with 129. So as I already discussed, I will not take here 100 as the standard base, but I will take the standard base as 10. In this case, the standard base, I'll take it as 10. And the multiple of 10 nearest to 122 and 129, that is 120. So I will take the non-standard base as 120, and 120 is 12 times 10. So in this case, the non-standard base is 12 times the standard base. So We'll follow the same procedure here. So 122 and 129. Now, since the non-standard base is taken as 120, 122 is 2 above the non-standard base, and 129 is 9 above the non-standard base. So multiply 9 into 2, 18. And if I cross add 122 plus 9 or 129 plus 2, both will give me 131. Now in this case, 131 is a number that is in base 120. So let me change it to a base 10 number by multiplying by 12. So 131 multiplied by 12 will give me 1572. And since I'm taking the standard base as 10, I'll keep only one digit in the right partition and I will carry forward this one to the next partition. I'll add 1 to 1572. That will give me 1573. So the product 122 multiplied by 129, write these numbers together. It will be 15738. 15,738. So the method is almost similar to the standard base method, but here only after cross adding whatever number you are getting in the left partition, you have to change it to the base 10 number by multiplying the number of times the non-standard base is to standard base. So let us take one bit difficult example here. So using this particular method, suppose I want to square 50015. I want to square 50,000 and 15. So here you can easily guess that non-standard base we can take the non-standard base as 50,000 and we'll take the standard base as 10,000. Because 50,000 is a nearest multiple of 10,000. And as we can see here, the non-standard base 50,000 is 5 times the standard base 10,000. So let us follow the same procedure, write 50,000 and 15 in the first column, one below other. Now 50,000 and 15, it's 15 excess of 50,000. So in the second column, we write 15 and 15, one below other. Now 15 multiplied by 15 is 225. And if I cross add, I will get 50,000 and 30. Now let us change the number in the left partition to the base 10 number, that is standard base number. So I will multiply this by 5 because the non-standard base is 5 times the standard base. And that will give me 2, 5, 0, 1, 5, 0. 250,000, 150. Now keep it in mind that the standard base here is 10,000. That means there should be 4 digits in the right partition. So I will write the 225 as 2, 2, 5, and 0 here. Because there should be 4 digits here and the remaining number 2, 5, 0, 1, 5, 0 here. And hence, we'll get the square of 50,015 as 2, 5, 0, 1, 5, 0, 0, 2, 2, 5. That will be 2,501,500,225. So wish this easy method is clear with you. So I will give you some problems for practice. I will give you the answers. You have to just verify these products using this particular method. So this is just a practice for you. In this practice problems, we'll just verify the following. So first is 79 into 75. And verify that this product is 5,925. Then 620 multiplied by 631. And that should give you 391,220. 391,220. And the square of 60,045, and that should give you 2. Just try these problems as a homework, and we'll meet shortly by taking some more interesting tactics in Vedic mathematics. So see you soon, friends. Enjoy the day. Bye.